Okay. We're actually going to go into transforming sinusoidal functions and degrees and radians. We just went over how to convert degrees and radians. So if you don't know that, you're going to rewatch that video for degrees and radians. And what we're going to do is get into what sinusoidal waves look like. So I'm going to bring up another page here. And we're going to create our own graph out of this. We'll just start over here. So I'm just going to start in the positive range. So think of this as being our y and this being our x, right? When we do these, we normally go in terms of 90 degrees. We go up by 90, then this would be 180, 270, yeah, 360. And we continuous because this is actually a pattern that keeps going. So 450, 540, we get a certain pattern like that. What we're going to do is the first wave is y equals sine x, our sine wave. It doesn't just start here, but there are 5 key points you need to know. One of them starts at the origin, one of the points, okay? We'll call this 1. This will be 1, 2, 3. This is -1, -2, -3. Okay, our next key point is at 90 and 1. Okay, we have another key point at 180 and 0, 270 and -1, and 360 and 0. Okay, and what ends up happening is it creates this type of pattern as we go through this. We have a wave-like pattern. So we can deduce that 450 is going to be up at 1 again. 540 will be where? At 0 again, right? And we just kind of continue this pattern. So actually, let's write this as if we're in red so that we know. That's our sine x wave. Okay, that's the original wave for that. Cos is a little different. It starts at 1. Continues the same type of pattern, goes down. Okay. At 80, it's 180 is -1, 270 is 0, 360 is 1. Okay, so this pattern almost looks like it makes a U-type, which means at 450, where are we?
Okay.
What is that?
0.
0, yeah. And then 540, we're going to be where?
-1.
-1, right. So there's our pattern for our cos wave. And your tangent wave is very different. Now, you said you guys haven't gotten into tangent waves, so we're going to leave that for now. We're just going to focus on these 2 waves to start. Okay? Now, what I want you to realize is, if you recall, we had, when we were transforming all types of other functions, we had a function that said something like this. A to the function, and in this case, we'll call it sine, okay, times k bracket x minus, I think it was d, plus c, is that right?
You put B inside.
What does he use? B and D instead? Okay, the letters aren't in the word. Actually, I think D is usually used outside. Okay, we'll use B in there. So here is your B, and we'll call this D. The letters aren't important. You can name them anything you want. What's important is they do specific things. If you recall these, we've used these letters before with other functions. They all do something, right? A gives us vertical stretches and compressions, and flips things on the y-axis. Okay? Sorry, x-axis. So let's try to make sense of that again. So A stretches and compresses, so I'm going to say SC, and flips things on the y-axis. Okay? Important to remember that. K stretches and compresses. Okay? I'm going to say compresses and stretches because it's actually vice versa of how A does it, and flips our functions on the x-axis. B moves things horizontally, left and right. So the only thing is it's counterintuitive. Positive is to the left, where negative is to the right. And D moves things up and down, positive though being up, which makes sense, and negative being down. So depending on what value we have. And whether it's sine or cos, it's the exact same idea. Okay? So with that being said, let's say I change the function a little. I call this function, to start off, let's talk about the a compression. So let's say y is equal to maybe 3 sine x. Well, this is only an a. So what that does is it takes all my y values, and we always try to do our stretches and compressions first because it's easier to think of it this way. If we do it to sine, well, we're going to multiply each of the y values. So we have a y value at 0, 1, and -1. We're going to multiply them by our a, which is 3 in this case. So what is 0 times 3?
0.
0. So that point's going to stay the exact same, and we're going to do this new graph in blue. Okay. Well, what's 1 times 3?
3.
So our new peak, or our highest point, our max, is now 3. What's 0 times 3?
0.
So we still come back down there. -1 times 3?
-3.
-3, so it comes all the way down here. And you see how this vertically stretches our sine wave, right? You see that's much longer, or pulled up and down farther than the original red one was. Still went through the same 0 points though, okay? Okay, so we've got that idea. What about y equals, and this time we're going to go sine. Now, what we're going to do in this case is, because it changes it a little, the little stretches, it compresses. So I'm going to say 2x. What letter does that represent, that 2?
K.
K, good. That's a K value. Now, remember, K is counterintuitive, okay? What it does is we're going to take all those values and we divide by our K. We take all of our x values and divide by K, okay?
So with A is multiplying?
Yeah, with A you multiply by the value, whether it's greater or less than, right? K you divide your x points by your K value. So let's think of this. Our cos, that was our green one. So we're going to do this new one in purple, okay? Our cos. Well, I'm looking at the x coordinates. My x coordinate here is 0. So what's 0 divided by 2?
0.
0. So my point is still here. Oh, sorry. It's still here at 1, right? What's 90 divided by 2? 45. So what happened is this 0 point now moves over to the left. It's half as far. So then we move over 180 divided by 2. 180 divided by 2 is going to be our 90. So for our green function that was here, it moves over here. Okay? 270 divided by 2 is going to put us in between, which is like 135. So our 0 point moves over to 135, which is here. And 360 divided by 2, okay, there's our 360, is 180. So that point moves over to 180. So if you notice, it makes the U wave, that starts with the cos, but it's more frequent, the period. See, the period before was 360 degrees, how long it took to go back and forth again. This one, if we continue it, goes over 2 periods, so the period is only 180. It's happening twice as fast as the original cos. Okay, so that's what our A and our K do, which are somewhat a little harder to see, okay, from what we have here. Now finally, we're going to talk about the other two, B and D. What we'll do is with, I don't want to draw it on there because it's getting a little confusing. Actually, we'll try to do it all in one shot, the B and the D, because the B and the D aren't that hard. We'll do a sine. Actually, we'll do cos because it's a little less common. Let's do cos x plus 90 plus 2. Okay? So let's talk about that. What two letters are though? What is the 90? The 90 is what?
B.
B. Okay, so we know that's going to be horizontal movements. And the 2 is? D. That's right. So I mean we have vertical movements. So let's take our original cos. You know, it starts here. We know we got to go up to 1, 2. So we're going to be here. It also moves everything 90. Positive direction. So positive direction is which way?
The left.
The left. So all of those points move to the left 90 degrees. Okay? So in other words, our cos, here's our 90. It goes over 1, 2, 90 degrees to the left. It goes 90 degrees to the left and up to 1, 2. So here's a point for us. We'll do this one in, what color do I have left? Black. He's going to be here. This point here at 180 for our coast goes over 90 degrees and then goes up 2 units. 1, 2. So it's going to be right there.
So what you're saying with B is that you
find each of those key original points.
And then you go over to 90?
Well, because it told us to go to the left 90, we go to the left 90. If it told us to go to the right, we go to the right.
So if it say we're on 360, you're gonna go all the way back to 90, right?
Mm-hmm. Well, no. If we're on 360, we can go all the way back to 90. From 360, we go back to 270. That's what a 90-degree shift would be.
You go over 1.
Yeah, we go over, it looks like 1 unit. It depends what your scale of your graph is. Okay, so with that being said, 270 is our next point. With our coast wave, the green one's our coast wave, we go over 90 degrees and up 1, 2, right? Because it still tells us to go up 2. We're making 2 movements at once here. Left and right and up and down. So this is there. At 360, go over 90 and up 2. So it's going to be there. So if I kind of just complete this final one, and then 450 was over 90, up 1, 2. If you notice, there's our period again. Okay, and then I can kind of continue that pattern.
It looks slower.
It's the same as the green one from before. It just looks a little different. That's all. But this is the one we've done in black here. This we did red, green. We did this guy in blue, and we did this guy in purple. Okay, so that's everything we did. I know it's a lot. The graph starts to get really confusing at the end there, but those are all of those movements. The thing I did want to talk about, we didn't, is the only thing that can kind of change in here is our graph doesn't no longer have to be, or doesn't need to be, in degrees anymore. 90, right? 90 is what in terms of our radians? Do you remember?
Pi over 2.
Yeah, so all we got to do is change this. This now is just a pi over 2. The waves themselves don't change at all. So we just change these. 180 would be,
Pi.
270 would be,
3 pi over 2.
yeah. 360 would be,
2 pi.
450 would be.
I don't know.
Okay, think of this as 1, 2, 3, 4. This would be
5 over 2 pi.
5 pi over 2. Good. This would be 6 pi over 2, but that can be reduced.
2, 8, don't tell me. 3
Yeah.
over 1.
Yeah, 3 pi over 1, which is just 3 pi. So we can kind of reduce it like this. So now we're in radians. That's it. We only change the x value. And we can go in the negative direction also. But that's using degrees in radians. We did everything in degrees to start. We could have done everything in radians. It relates perfectly back to that circle we had done before also. Okay?